All right, so now moving on to the next section of this unit, and that's going to be section 7D, and we're going to be discussing independent and dependent events, and also how we can find the probability of each of these types of events. We did talk about in the years past about what independent and dependent means, both in science and in math. So hopefully you guys have an understanding of this already, but if not, we're going to go through each of these types of events and how to calculate the probability. So what you'll need to know by the end of this video is hopefully you know the difference between an independent and dependent event, and also how to calculate the probability of both types of events. All right, so let's go ahead and start talking about what an independent event is, and then we'll get into calculating the probability. All right, so compound events that we just learned about, they may be independent or dependent events. And events are independent if the occurrence of one does not affect the likelihood of the other. So if we are spinning a spinner and rolling a die, what I spin on the spinner has no effect whatsoever on what the die is going to be rolled. So those will be independent events. So when they don't have any effect on each other at all, that no matter what happens with the one, it can't affect the outcome of the other. Flipping a coin and rolling a die, those would have no effect on each other. So if we're trying to see what are the odds of us rolling a 3 and flipping a heads, well, it doesn't matter if I flip a heads, it's not going to all of a sudden make it more likely that the die is going to roll a 3. They're completely independent of each other. The events have no way of affecting the outcome or the likelihood of one or another. And in order to find the probability of independent events is we simply just multiply the probability of each individual event happening together. So if I'm saying what are the odds of flipping a heads and rolling a 3, well, we would do the probability of a heads and 3. Well, to find this probability, well, the probability of a heads is 1 out of 2, and the probability of a 3 is 1 out of 6. So since they don't have any effect on each other whatsoever, we can just multiply them together to say, well, the probability of us flipping a heads and rolling a 3 is 1 out of 12. All right, and this can extend to and however many events we're doing. If we're doing spinning a spinner, flipping a coin, and rolling a die, well, then we would have another event, which is why we also talk about the probability of A, B, and C being multiplied together. So if the events are independent, we simply just multiply the probability of each event happening, and that gives us the total probability of both events occurring. All right, so now from here, we're just going to go ahead and go through some examples. All right, so here it says you spin the spinner and you flip the coin. What is the probability of spinning a prime number and flipping a tails? So we want both to happen. So we're looking for the probability of prime and tails. So in this example, when we're doing this, they're independent of each other. What I spin on the spinner has no effect on how this coin will be flipped. So when we're doing this, we should identify, well, how many events do we have taking place? So we have 2 events. We have event 1 and we have event 2. And for event 1, we're going to say spinning a prime number. Well, prime numbers are numbers that their only multiples are 1 in themselves. So, but 1 is not a prime number, 2 is a prime number, 3 is a prime number, 4 is not, and 5 is a prime number. So our event 1, the likelihood of us spinning a prime number is 3 out of 5. And since they're independent of each other, I don't have to worry about adjusting the probability for my next event. I just need to go ahead and say, okay, well, what am I trying to look for? I'm trying to flip a tails. Well, now what are the probabilities of us flipping a tails? Well, that's 1 out of 2. So to find the probability of both happening is we just simply need to multiply them together. So 3 out of 5 times 1 out of 2. Well, we know that we just multiply across. So 3 over 3 times 1 is 3, and 5 times 2 is 10. So the probability of flipping a tails and spinning a prime number is 3 out of 10, or 30%. All right, so when we're dealing with this, the first thing we need to identify, is it independent or is it dependent? Because we're going to learn soon that when it's dependent, it does change these calculations a bit, because we have to figure out, well, how does the first event affect the second? When it's independent, we don't need to really worry about that. We just think about the likelihood of each event happening and then just simply multiply them together. All right, so now the next type of event that we have to be able to understand are dependent events. And dependent events is if the occurrence of the one event does affect the likelihood of the other. So when we're dealing with this, we have to think, does the first event that we're taking place, does it actually affect or can it affect the likelihood of the second event occurring? And since flipping a coin and the spinner are like completely two different things that we're doing, they can't have an effect on each other. However, what if we're picking cards out of a playing deck and we say, okay, what are the likelihood of us choosing an ace and then choosing a two if we don't put the card back in? So if I pick a card out and it's an ace and I don't put it back into the deck and I leave it off to the side, well, the total number of cards that I have has changed. So now that is affecting the probability of the second event. And we have actually seen this throughout this year. Whenever we've used that random spinning wheel, that actually is a dependent event. And I'm going to show you that right now and explain what a dependent event is and how it's changing the likelihood of the event occurring. All right, so we've used this spinning wheel to determine who's going to pick their seats first and other things as well. If we were to think about this, and we have 1, 2, 3, 4, 5, 6, 7. All right, so if I said, okay, when we spin the wheel, what are the odds of us picking Steve or whatever it may be? Well, it is a 1 out of 7 chance, right? Now we spin the wheel, or let's just say Chris, because that's who I know that the name's going to be. So it's a 1 out of 7 chance because there's 7 names and there's 1 chance of picking Chris on that spinning wheel. But when your name got picked, I took it out of I removed it from the group. So if Chris were to get picked, I always selected remove name, so that way it no longer was part of the group anymore. And when we were picking the next name, Chris was no longer an option. So let me show you that again. So after we removed Chris's name from the wheel, we now only had 1, 2, 3, 4, 5, 6 names to choose from. So you see, we started with 7 the first time we did this, but after we chose someone, we removed them from the wheel, and now there's only 6 names. So the odds of me picking anyone in this first wheel was 1 out of 7. But then after I removed the name, it then became 1 out of 6. So you see, this event, the first one, does affect the probability of the second one because we removed the person from that spinning wheel. So because we did that, it is a dependent event. So if we were to find, well, what is the likelihood of selecting Chris? Whoops, let me spell that correct. What is the probability of selecting Chris? And let's say and Carl. Well, when we're looking at this, our first event is Chris, and then our second event is Carl. Well, the odds of picking Chris is 1 out of 7 because there's 7 names. When we're doing this, we are assuming that the first event that we want to take place does happen, right? Because if it doesn't happen, it's not really going to help us with this because we're saying, what are the probability of this specific event, that Chris and Carl? So we're acting after this first one. Well, we did pick Chris. And after we pick Chris and remove his name from the wheel, now Carl has a 1 out of 6 chance of being picked. And then to find a probability of these two is we would multiply them together just like we do with an independent event. And now it becomes 1 out of 42. So you see, unlike with the independent, we just found the probability of each event and then just multiplied them. Here we had to think about how does the probability change after the first event. And we always assume that what we want to happen in that first event does. Right? Because if we look at any of the other names, well, that's not giving me the probability of Chris and Carl. We're now looking at other events that we're not focusing on. So we want the event that we want to occur to happen. And we're going to treat it like it does. So you see, by removing Chris's name, it changed the likelihood of the second event happening. So we have to take that into consideration. So when doing these questions, 1, we have to determine, are they dependent or independent? If they're independent, it's easy. We don't need to think about how they affect each other. We just simply find the probability of each event occurring and multiply. Well, when they're dependent, we have to say, okay, how does the odds now change for this second event? So let's go ahead and do a couple examples. All right, so the first question we're going to do now is finding the probability of a dependent event. People are randomly chosen to be game show contestants from an audience of 100 people. You're with 5 of your relatives and 6 other friends. What is the probability that one of your relatives is chosen first and then one of your friends is chosen second? All right, so now, this is a dependent event because when someone is selected, that person isn't going back into the audience. They're now part of the game show. So they're removed from the 100 people in the audience. So that audience now will narrow down to 99 after that first person is selected. You're not selected to be part of the game and then you go right back and wait for the very next one. So you are not part of the next group of people that are selected. So what we're trying to do now is we're trying to find a probability. And remember, the probability that they're saying is that first is your relative, so relative, and the second is your friend. So this is the probability that we're trying to happen. So I'm going to list out the two events. We have our relatives, and then we have our friends. Well, what are the odds or the probability of a relative being selected? Well, we have 5 relatives, and there's 100 people. So the odds of us picking our relative is 5 out of 100. So now, after we pick that first person, remember, we are assuming that what we want to happen does. Because if the person's not a relative, well, then it doesn't help us with this question. We're not able to solve for this probability then. So we're assuming that the first person that is selected in this group is our relative. Otherwise, it's not what we're trying to look at and find. So we're always assuming that what we want to occur does. So after our relative gets picked, we no longer have 100 people in the audience. We now had 99. Well, the amount of relatives doesn't affect the amount of friends that we have. So that's going to be 6 out of 99. Once we figure out the likelihood or the probability of each event, we can then multiply these together. And now I'm going to just multiply these together off to the side. So we have 5 out of 100 times 6 out of 99. Rather than multiplying, which you can because you can use a calculator, I'm just going to reduce these and get 1 over 20 because they're both divisible by 5. And then these are both divisible by 3. So I'll get times 2 over 33. And then we will multiply our numerator with our numerator and get 2. And then our denominator with our denominator, which is 33 times 20, which is 660. So that will give us our fraction. Remember, I do want you guys to start doing this in decimals or percentages. And 2 out of 660 is equal to 0.003. Or if we wanted to write this as a percentage, we can go 1, 2, so 0.3%. So either of those would be acceptable, 0.003 or 0.3%. I do want you to write your answer as a decimal or a percentage and not as a fraction, because if I ask you to describe the likelihood, it's a lot easier when it's written as a percentage or decimal than it is as a fraction. All right, but the main thing you have to take from this is we have to be able to identify, does the one event affect the other? And if it does, we have to take that into consideration when we're figuring out the odds of that second event happen. So since the person is not going back into the audience, that changed the amount of people that we're picking from. All right, so that's the way that we are doing this. All right, so now I believe there's one more question and we're done with this video. All right, so the directions for this question does say find a probability of a compound event. We've already been doing compound events though, because remember, a compound event is just 2 or more events that are happening. And all the other examples we did were 2 events, at least. The one was spinning a die or spinning the spinner and flipping a coin. So that's 2 events. And then the last one was picking your relative or your friend. That's 2 events. Now this one, notice compound is going to actually have 3 events. So it says a student randomly guesses the answers for each of the multiple choice questions. What is the probability of answering all 3 questions correctly? So what we're trying to find here is the probability of all 3 correct. Right, that's what we're trying to find. Now, there are 3 events. We have question 1, we have question 2, and we have question 3. Are these events independent or dependent? Whether you guess number 1 right or wrong, that's not going to change the likelihood of you guessing the next one. Because if you guess it right, it doesn't narrow down the choices. It doesn't eliminate a wrong choice for you in the second question. Or if you guess it wrong, it doesn't eliminate one. So each event is independent of each other. So what we need to do then is figure out what are the odds of you guessing the question right. If you have no idea and you're just going to randomly guess, well, you have 5 choices and only one of them correct. So you have an odds of 1 out of 5 of selecting question number 1. And the same thing for question number 2. There's 5 choices and you have the odds of 1 out of 5. And the same thing for question number 3. You also have 5 choices. So it is also 1 out of 5. So then from here, what you will then do is once we figure out the odds of each of these events, we will then multiply them together. And it becomes 1 out of 125, which is going to be equal to 0.008 or 0.8%. All right, so our likelihood or the odds of you picking randomly all three of those choices correct is less than 1%. So we had to determine, was it independent or dependent? And we knew that it was independent. So once we just do that, that just means we don't really have to worry about how one event affects the other because there is no effect on it. And then once we do that, we're always just figuring out, well, what is the probability of each individual event? And that's why you're seeing me write these like lines with the event underneath, because it's allowing me to focus on them individually. And then once we figure out the odds of each event happening, we just simply multiply them together to get the probability of all the events taking place. All right, that is it for this video.